Alright, so yesterday we talked about the electromagnetic spectrum. We just got done doing some demos of different spectra and different colors, and talked about why the electrons get excited and get ripped off of the element in question. So now we're going to figure out today, we're going to learn how to do, whether to figure out the frequency of a wavelength, or the actual what is the wavelength itself based on its frequency and speed, and we can even figure out the energy of the wavelength if we know what the wavelength is. So let's start with the first two questions that we already did on the board. I'm just doing them again in case you need to refresh, or I went too fast, or there's a step that you did not understand. So the formula we're using on this front side, speed, frequency, and wavelength, is C equals lambda nu. So we know that lambda is the symbol for the wavelength, and that the V or the nu sign is the symbol for frequency. So C is our constant. It's going to be 3.0 times 10 to the 8th meters per second. And by knowing these three pieces of information, as long as we know one other piece, we should be able to figure it out. So it says violet light has a wavelength of 4.10 times 10 to the negative 12th meters. What is its frequency? Okay, well, we can figure that one out. So let's plug in the formula. So we know that C equals lambda nu. And we have wavelength, so we got to find V. So V equals what? Well, if we do our algebra, since the wavelength sign is attached to the V, we have to get it away from it. So by doing that, we got to do the opposite of it. So let's divide both sides by that symbol. Let's cancel it out. So V equals the speed of light divided by the wavelength. Well, we know the speed of light is a constant, so 3.0 e to the 8th. Remember, the e means times 10 to. So we're going to take that, we're going to divide it by 4.1 e to the negative 12th. So once we do that, we simply plug it into the calculator and we get our frequency. So remember, on the calculator, I'm going to move this up so you can see the steps. You would do 3.0, hit the second button, the comma button, which gives us the e to the 8th. And then we're going to divide that by 4.10, second comma again. This time we got to hit the negative button because our exponent is negative, so negative 12. And then we simply hit enter, and that gives us 7.32 e to the 19th hertz, because frequency is measured in hertz. So that's not too bad. So let's do the second one. Let's clear the calculator. Let's move this up a little bit. Okay, so green light has a frequency of 6.01 times 10 to the 14th hertz. What is the wavelength? So we're going to use the same formula. C equals lambda nu. Remember, that's wavelength, that's frequency. So now we're solving for frequency. So frequency equals, well, it's going to be the same thing, algebraically wise, to get the answer. If you don't know how to do it, you divide both sides by whatever's attached to it. So we're looking for that. So we're going to divide by V. We're going to cancel them out. So we're going to do C divided by V. Speed of light divided by the frequency. So then we do 3.0 times 10 to the 8th. We're going to take that, we're going to divide it by its frequency, 6.01 e to the 14th. So then we simply plug it into the calculator. So we do 3.0, second comma, we hit the 8, divided by 6.01, second comma, 14. Remember, the e means times 10 to. So we do that, and we get 4.99 e to the negative 7th, and our wavelength is going to be meters. There's the first two. The rest of these on this side are very similar. I give you hints if it's something out of the ordinary. So we're going to flip it over. Now we're going to talk about the energy of wavelengths. So some of these you're given wavelengths, some of these you're actually given the frequency, but if you're given wavelengths, so we'll do number 9 and we'll do number 11, and we'll show you how it works. So this says calculate the energy of a photon. Well, let's talk about the formula first. So the formula is energy equals h times the frequency. H is going to be what's called Planck's constant. It's always going to be the same. It's 6.626 times 10 to the negative 34. And this means joules per second because our energy is in joules. Our frequency is hertz, and our H is just a constant. So hertz is, you can measure hertz in seconds if you needed to. So we're going to calculate the energy. So energy equals, let's go ahead and plug in Planck's constant, 6.626 e negative 34. We're going to multiply it by the frequency of 8.5 times 10 to the 14th. Okay, so then we plug it in our calculator. We would do 6.626 second comma negative 34 times 8.5 second comma, oh, I didn't do second comma, I just did comma, second comma, 14. That's going to give us 5.632 e to the negative 19 joules. Joules is the measure of energy. So that should be our answer. So the ones that are a little bit tricky are the ones that give you wavelength. So, because they're a two-part problem. So I'm going to do the last one because I have a little more room. So what is the energy of light whose wavelength is that? So first step is we got to figure out the stinking frequency. So we do C equals lambda nu. So we're solving for wavelength. So wavelength equals C divided by V. So it's going to be 3.0 e to the 8th because from the back side, that's the speed of light. It's a constant. And, oh, sorry. We're solving for frequency because we're given the wavelength. I'm sorry. I just wrote that down wrong. So our wavelength is this. So then we divide 4.06 e to the negative 11. That's going to give us our frequency for this specific problem. So then we would do 3.0 second comma to the 8th. Divide that by 4.06 by the negative 11th. So that gives us a frequency of 37.3, let's round it to 9, e to the 18th. So now that we have the frequency, we would plug it into the energy equation. So energy equals Planck's constant of 6.626 e to the negative 34th times this number. So then we would take that number. I still have it in my calculator. I would just leave it there. Don't clear it out. And then we just do times 6.626 second comma negative 34. And that's going to give us energy of 4.896 e to the negative 15th joules. So that's a basic synopsis of basic energy, frequency, wavelength problems, and also of speed, frequency, and wavelength problems. Again, you should be able to do the rest of these on your own. If you need help, you know who to ask, you know where I'm at, and hope you enjoyed.